Hello, I'm Maris, a senior security engineer at Spotify. But today's talk isn't going to be about security. Today's talk is going to be about functional optics and how to use them in React. So, functional optics has been a subject that has been like on my radar to discover and try to find a use case for, but I haven't really found any way to do it. So the first point of today's agenda kind of explains that. So Cleva is a library that I've written, which is a state management library that has functional optics built in from the start. So it was sort of a way for me to, or an excuse for me to write my own state management library. However, while building this, I realized that actually it should be possible to add to any state management library. However, there's almost no support for that in different libraries. So that's what's special about Cleva. It's a way to kind of learn how to use functional optics in React. And I've built some projects with it, and it's really nice to work with. So yeah, that's the other thing. Okay, so we kind of talked about what Cleva is. So let's go into what an atom is. Atom is like the primary way to store some kind of state in Cleva. So let's install Cleva. I don't know what happened there. Okay. So what's an atom? An atom stores some kind of state. So let's make, we have this example with the counter. Let's make a counter atom. And let's initialize it with the value 0. Okay, so there are three things you can do with an atom. First is you can get its value. So let's log that here. And let's see what happens in the console. Okay, so value is 0. The second thing you can do with an atom is you can update it. So let's send in the new value 2. To update it, you can either just send in the new value that you want it to be updated with, or similar to the setter function in React's use state, you can send in a callback. The first argument is the old value, and you can just increment the old value. So this is, we started with 0, we updated it, plusing it with 1, then we have 1. Okay, and the third thing we can do with the atom is we can we can subscribe to any changes to it. And the subscribe function takes a listener, which the listener's first argument is the value, and the body is basically what we want to do with that value. For this example, let's just log it out. All right, so first we log the value here. Then we subscribe, and then we update it, and then we log the value here. Let's update it again. Should get a 0, 1, 2. Okay, so that's it about atoms. So what are optics? Right, so let me first demonstrate the problem. Never show the key without first showing the door. So let's say that we have some kind of complex state in JavaScript. It's an object which has multiple keys, A and B, or something like that. It's easy for us to, in a redirection, get a reference or get A, which is fine, but, or let's say like this. We can get a reference to A. However, if we try to change A, set it to 5, then object state.a won't have that change reflected. It's only A, the variable, that's changed. So anybody who's reasonable, I guess, or has read how JavaScript works, knows that it doesn't work this way. However, atoms sort of make that possible. So let's move this object state into the atom like this. And let's call this object atom. And let's change this to instead increment A. What we'll do is we'll do this classic routine, old value.a plus 1. So what happens now is we increment A. However, this is cumbersome and kind of boring to write. So what we can do using functional optics is to get a read and write atom which only cares about the A key. So let's create an A atom and use focus atom to focus on the A key. So the first argument to focus atom is the object. The second argument is something that I call an optic callback, which gives us an optic where we can construct other optics from it. So if we just leave it like this, then A atom would be an atom which refers to A and B. And it would just mirror object atom completely. So we could do A atom subscribe to value, A value, object value, and then we could update A atom like this. Both of these mirror, so A atom completely mirrors object atom. If we have subscribed to one, then we see the values change in both subscriptions. And if we update it, we see it. However, we want to focus on only the A key. So the way to do that is via one of these prop constructors, or the prop constructor, where we'll send the argument A. This will cause a compilation problem here, because old value will be a number, because A is a number. So we can remove this code. Oh yeah, like this. And what we have now, the A value is just 1. If we update object atom with the new A value, then we'll have the new value, which is here, because it went from 0 to 1. And the second update, we'll see that A is 2. And the same thing is done here. Right, so I think that for me at least the point of optics is simply to make code easier to read, because instead of having to worry about this stuff, we can just simply like update A, because we only care about A, or maybe that section of the code only cares about A. Right. So that's one thing. Let's remove the ObjAtom subscription. So right, how do we use Cleva in React? So the way we do it is there's a hook called useAtom, which basically mirrors useState. However, it takes an atom as its first argument. So since this is a counter example, if you've noticed, there's a React application running which has a counter. Let's just send in a atom, and the a atom will be our count. Okay, so the count is 1, even though we initialized it as 0. This is because we updated it here before the app was rendered, and it became 1. Let's just remove this update. All right. So if we click +1, or if we click this button, it should increment the count with 1, as you can see. And we see in the log that the subscription is being called. A value is 5, count is 5. That's basically it. Let's we can use this more. For now, this is all we need to build the to-do app, or at least part of it. Okay, so let's clean up here. Let's build the to-do app. So I'm going to remove this comment now because we have nothing else to do on the agenda. Clean up this code. Okay, we're compiling, that's fine. So my idea is to start from the bottom somehow. A to-do application has lots of to-do items, and the to-do items have some kind of done state or checked state, and also a description. So let's just start with the simplest thing. One to-do item with one checked state. And that checked state can be represented by an atom. We'll start it with the initial value can be false. Done atom. So let's create a component. Oh, and let's use get the value from the done atom. Looks pretty much like you would do it in using useState. Okay. Oh, and we have to initialize the to-do item. All right, so we have a to-do item. As you can see, if we click it, it will change and it will update the atom, which is cool. But we probably want a description as well. So let's make the atom more complicated by adding a description. So let's name this to-do atom. Done should be initialized with false, and description should be initialized with go for a walk. All right, so since this is a to-do atom, we should probably rename this to do and set to do. And this one should only consider the done attribute. Same here, actually. Done. So we only update the done attribute in our little event listener here. So as you can see, we've made it a little bit more complicated, but it's working as expected. However, let's give the description an input as well. We type text instead. And probably something like this. Okay, so now we can edit the description as well, which is pretty nice. However, since this is a talk about functional optics, I won't allow this kind of code. So since the checkbox only considers the done attribute and and only considers the done attribute in the read direction and in the write direction, then we could probably simplify this code using optics. So let's make use of optics instead. So I'm imagining that we should have something like this, done set done, where we use atom on something, maybe done atom. So how do we create a done atom which only considers the done attribute? Well, by using focus atom. To do atom, send in an optic callback, and we focus on the done property of the to do atom, or of the value in the to do atom, as you can see. So okay, seems to be compiling. Let's just switch this out, set done. Right, it's updating as expected. The done attribute is being updated. So let's give the description the same treatment. But description atom instead. Like this. Seems to be compiling fine. Let's switch it out down here as well. Oh, oops. Right, okay, so it seems to be working. The description atom can update the description like expected. So now we can just remove any reference to or any use atom which considers the whole to do, because we have atoms considering parts of the to do instead, which is a little bit nicer code to look at. So we have a to-do item. However, we would probably want more items in a real application. So how is this done? First of all, let's make our to-do item take a to-do atom as a property. Right? And then let's send this prop it should compile. So I'm thinking we can initialize many to-do items, each with their own to-do atom now. We've kind of set the stage for that. So let's change this to be a to-dos atom and change this to become a list instead. Also, I'm just gonna make this a little bit nicer to look at now using Stringify. So now it's complaining because to-dos atom is an atom with a list of to-dos, while it's expecting a atom with a to-do. So how do we slice this to-dos atom from an atom containing a list to a list containing atoms? Well, that's what Cleava is named after, because Cleava means to actually cleave stuff, or yeah, in Swedish, cleava. So let's use the use atom slice hook to slice this to-dos atom. To-dos atom. And using this hook, we now get a list of atoms. So now we can just map this list. I should probably use some kind of key as well to make React happy. To-do atom. Okay, so the app seems to be compiling. There's only one item because the initial state is only one item, but we're getting updates as expected. So if we change done from true to false or false to true, it's updating accordingly. Let's just add another item here to make it a bit more interesting. Eat a snack, maybe. Okay, so now we have two items. And if we change one, that is changed as expected. Okay, so let's create just a function a button to add a new item. Add new item, to-dos atom update. Let's just append it. Let's just do it this way because it's simpler. New item, and done is false. Okay, so we have a function to add a new item. Let's just add a button to call that function. Add new item. Add new item. Okay, so when we click this, we shall see a new item here, and if we click it again, we see a new item again. And we can make changes to it. This is cool. Almost a complete application. Seems to be working all right. if you noticed, this atom is removable, or the list returned from the atom slice list is removable, or the atoms in the list are removable. So the only difference between a removable atom and an atom is that a removable atom has an extra attribute called remove, or an extra function called remove, which it can call to remove itself. So let's and TypeScript accepts us sending in a removable atom where it expects just an atom, because it's okay to include an extra attribute. So let's change this to removable atom, and let's add a button to call the remove function, or it was called to do button remove. All right. So what happens now if we add a new item, get a new item? If we press the X button, which we'll call the remove button, for any item, it will remove that item, as expected. Cool. So that's basically how you build a to-do app in Cleava. I think this way of working with global state is pretty clean, especially since the to-do item really doesn't think it works with global state, just takes a to-do atom property and does stuff to it. It doesn't know that it's global state it's working with. Also, thing to consider, we didn't use any use memo or anything like that. However, if you notice, let's add a few items, and let's make a mutation to one of these. There isn't, oh, oops. When we make a mutation, the other items aren't rendering. Only the item where we made the mutation is rendering. This is one of the good things about Cleava. We didn't have to do any, avoid any rendering or try to stop any rendering from happening in any sister components or the parent component, because with Cleava you subscribe to only the changes that are relevant for you. So if the done attribute or the description attribute changes, then this to-do item will re-render. Right. Thank you for listening.